The remainder theorem and its extension, the factor theorem, are fundamental concepts in algebra, especially useful for solving polynomial equations and divisibility problems. Here's a clear and thorough explanation of both. Blue circle remainder theorem statement. If a polynomial f(x) is divided by linear divisor of the form x minus a, then the remainder of this division is f a. Checkmark explanation. Let f(x) equals x minus a dot operator q x plus r. f(x) equals x minus a dot operator q x plus r where f(x) is a dividend polynomial. X minus a is a divisor. Qx is a quotient polynomial. R is the remainder, a constant because the divisor is linear. Now, substitute x equals ax equals a. Fa equals a minus a dot operator q a plus r equals 0 plus r equals r. Fa equals a minus a dot operator q a plus r equals 0 plus r equals r, so remainder equals Fa. Green square example 1. Find the remainder when x equals x3 plus 2x2 minus 5x plus 3. Fx equals x3 plus 2x2 minus 5x plus 3 is divided by x minus 2. X minus 2. Solution. Using remainder theorem. F2 equals 2, 3 plus 2, 2, 2 minus 5, 2 plus 3 equals 8 plus 8 minus 10 plus 3 equals 9. F2 equals 2, 3. Plus 2, 2, 2. Minus 5, 2 plus 3 equals 8 plus 8 minus 10 plus 3 equals 9. Checkmark remainder equals 9. Blue circle factor theorem. Extension of remainder theorem statement. If Fa equals 0. Fa equals 0, then x minus a is a factor of fx. Conversely, if x minus a is a factor of fx, then f equals 0. Fa equals 0. Checkmark example 2. Check whether x minus 1 is a factor of x equals x3 minus x2 minus x plus 1. Fx equals x3 minus x2 minus x plus 1. Solution. Use factor theorem. F1 equals 1, 3 minus 1, 2 minus 1 plus 1 equals 1 minus 1 minus 1 plus 1 equals 0. F1 equals 1, 3. Minus 1, 2. Minus 1 plus 1 equals 1 minus 1 minus 1 plus 1 equals 0. Checkmark since F1 equals 0. F1 equals 0. X minus 1. X minus 1 is a factor of fx. 8 spoke asterisk applications. Quickly find the remainder without performing long division. Check whether a given binomial is a factor of a polynomial. Useful in polynomial root problems, number theory for divisibility, and competitive exams like SSC, UPSC, and GATE. Repeat button short trick. For remainder of x divided by x minus a. Fx divided by x minus a. Just plug in a into the polynomial. Right arrow remainder equals Fa. Magnifying glass practice question 1. Find the remainder when x equals 2x3 minus 3x2 plus x plus 5. Fx equals 2x3 minus 3x2 plus x plus 5 is divided by x plus 2. X plus 2. Solution. Use x plus 2 equals x minus 2. X plus 2 equals x minus 2. So a equals minus 2. A equals minus 2. F minus 2 equals 2 minus 2 3 minus 3 minus 2 2 plus minus 2 plus 5 equals 2 minus 8 minus 3 4 minus 2 plus 5 equals minus 16 minus 12 minus 2 plus 5 equals minus 25. F minus 2 equals 2 minus 2 3 minus 3 minus 2 2 plus minus 2 plus 5 equals 2 minus 8 minus 3 4 minus 2 plus 5 equals minus 16 minus 12 minus 2 plus 5 equals minus 25. Checkmark remainder equals minus 25. Would you like polynomial long division examples too? You said. Simplification using BODMAS. ChatGPT said. Blue circle simplification using BODMAS rule. The BODMAS rule is used to simplify mathematical expressions in the correct order of operations. It ensures accurate results when multiple operations are involved. Large diamond. What is BODMAS? BODMAS stands for B brackets. O orders, powers, and roots. D division. M multiplication. Addition. S subtraction. Pushpin rule. Always solve expressions in this order. Right finger if multiple operations appear together. Like D and M. Solve left to right. Large diamond. Step by step example 1. Q. Simplify. 8 plus 2 times 3 2 minus 1. 8 plus 2 times 3 2. Minus 1. Small diamond step 1 brackets. 3. 2 equals 9 3 2. Equals 9. So inside the bracket. 9. Minus 1 equals 8. 9 minus 1 equals 8. Small diamond step 2 multiplication. 2. Times 8 equals 16. 2 times 8 equals 16. Small diamond step 3 addition. 8. Plus 16 equals 24. 8 plus 16 equals 24. Checkmark answer. 24. Large diamond step by step example 2. Q. Simplify. 36 divided by 3 times 2 plus 5 minus 4. 36 divided by 3 times 2 plus 5 minus 4. Small diamond step 1 division. 36. Divided by 3 equals 12. 36 divided by 3 equals 12. Small diamond step 2 multiplication. 12. Times 2 equals 24. 12 times 2 equals 24. Small diamond step 3 addition. 24. Plus 5 equals 29. 24 plus 5 equals 29. Small diamond step 4 subtraction. 29. Minus 4 equals 25. 29 minus 4 equals 25. Checkmark answer. 25. Large diamond step by step example 3. Nested brackets. Q. Simplify. 10 plus 6 times 3 plus 8 minus 5. 10 plus 6 times 3 plus 8 minus 5. Small diamond innermost bracket. 8. Minus 5 equals 3. 8 minus 5 equals 3. Small diamond curly bracket. 3. Plus 3 equals 6. 3 plus 3 equals 6. Small diamond square bracket. 6. Times 6 equals 36. 6 times 6 equals 36. Small diamond final addition. 10. Plus 36 equals 46. 10 plus 36 equals 46. Checkmark answer. 46. Large diamond important tips. Always solve inside brackets first. Orders mean powers like 2. 3 2 3. And square roots like 9. 9. Left to right for division and multiplication. Left to right for addition and subtraction. Memo practice question. Q. Simplify. 12 plus 18 divided by 6 times 4 minus 2 2. 12 plus 18 divided by 6 times 4 minus 2 2. Small diamond 4 minus 2 2 equals 2 2 equals 4. Small diamond 4 minus 2, 2 equals 2, 2 equals 4. 4 minus 2, 2. Equals 2, 2 equals 4, small diamond 18 divided by 6 equals 3. 18 divided by 6 equals 3, small diamond. 3 times 4 equals 12. 3 times 4 equals 12, small diamond. 12 plus 12 equals 24. 12 plus 12 equals 24. Check mark answer, 24. Would you like 10 practice questions with answers on BODMAS? You said, surds and indices, ChatGPT said. Blue circle surds and indices, complete concept explained. Understanding surds and indices exponents is essential for mastering simplification problems in exams like SSC, railway, banking, etc. Here's a crystal clear explanation. Large diamond 1, indices exponents. An index or exponent tells us how many times a number called the base is multiplied by itself. Example. 2 4 equals 2 times 2 times 2 times 2 equals 1 6 2 4. Equals 2 times 2 times 2 times 2 equals 16. Check mark basic laws of indices. Let A and B. B be real numbers, and N be integers. Multiplication. AM dot operator AN equals AM plus N AM dot operator AN equals AM plus N. Division. AM AN equals AM minus NAN. AM equals AM minus N. Power of a power. AM N equals AM N AM N equals MN. Power of a product. AB M equals AM dot operator BM AB M. Equals AM dot operator BM. Power of a quotient. AB M equals AM BM BA M equals BM. AM. 0 exponent. A 0 equals 1 if it is not equal 0. A 0 equals 1 if a equals 0. Negative exponent. A minus M equals 1 AM. A minus M equals AM. 1. Large diamond example 1, 2. 3 dot operator 2 4 equals 2 3 plus 4 equals 2 7 equals 1 2 8 2 3 dot operator 2 4 equals 2 3 plus 4 equals 2 7. Equals 128 large diamond 2. Surds. A surd is an irrational root that cannot be simplified into a rational number. Check mark examples of surds. 2. 3 5 7 3 11 2 3 5 3. 7 11. Large diamond rational numbers versus surds. 4. Equals 2 4. Equals to right pointing arrow not a surd because it's rational. 2 approximately equals 1.414. 2. Approximately equals 1.414. Right pointing arrow surd irrational. Check mark laws of surds. Dot operator B equals ABA dot operator B equals AB. AB equals ABB. A equals BA. SQRT a square equals a quad text if a get 0. ANM equals AN per meter M. AN equals AN per meter. Large diamond example 2, 2. Dot operator equals 16 equals 4 2 dot operator equals 16 equals 4. Large diamond example 3, simplify. 1 3. Rationalize 3. 1. Rationalize. Multiply numerator and denominator by 3. 3. 1 dot operator 3 3 dot operator 3 equals 3 3 3 dot operator 3. 1 dot operator 3 equals 3 3. Check mark final answer, 3. 3 3 3. Large diamond relation between indices and surds any root can be written in index form. A equals a 1 half equals a 1 half. A 3 equals a 1 3 3. A equals a 1 third. AMN equals AMNN. AM equals AMN. Large diamond example 4, convert to index form. X3 4 equals by 3 quarters 4. X3 equals by 3 quarters. Large diamond important note. When multiplying or dividing surds or indices, make sure the bases are the same to apply rules. Memo practice questions, simplify. 5. 3 dot operator 5 minus 1 equals 5 3 dot operator 5 minus 1 equals. Check mark answer, 5. 3 minus 1 equals 5 2 equals 2 5 5 3 minus 1 equals 5 2. Equals 25. Simplify, 18. Equals, 18 equals. Check mark answer, 9. Dot operator 2 equals 9 dot operator 2 equals 3 2 9 dot operator 2 equals 9 dot operator 2 equals 3 2. Simplify, 1. 5 plus 3 5 plus 3. 1. Rationalize check mark multiply by conjugate. 1 5 plus 3 dot operator 5 minus 3 5 minus 3 equals 5 minus 3 5 minus 3 equals 5 minus 3 2 5 plus 3. 1 dot operator 5 minus 3. 5 minus 3 equals 5 minus 3 5 minus 3 equals 2 5 minus 3. Would you like 20 MCQs with answers for surds and indices practice? You said, laws of exponents ChatGPT said. Blue circle laws of exponents indices full explanation. Exponents also called indices or powers tell us how many times a number base is multiplied by itself. The laws of exponents help simplify expressions involving powers. Let's go through each law clearly with examples. Large diamond 1, product of powers rule. M dot operator AN equals AM plus N AM dot operator AN equals AM plus N. Check mark when multiplying same bases, add exponents. Small diamond example. 2 3 dot operator 2 4 equals 2 3 plus 4 equals 2 7 equals 1 2 8 2 3 dot operator 2 4 equals 2 3 plus 4 equals 2 7. Equals 1 2 8. Large diamond 2, quotient of powers rule. MAN equals AM minus N, A does not equal 0, AN. AM equals AM minus N, A equals 0. Check mark when dividing same bases, subtract exponents. Small diamond example. 5 6 5. 2, quotient of powers rule. MAN equals AM minus N, A does not equal 0, AN. AM equals AM minus N, A equals 0. Check mark when dividing same bases, subtract exponents. Small diamond example. 5 6 5 2 equals 5 6 minus 2 equals 5 4 equals 6 2 5 5 2. 5 6 equals 5 6 minus 2 equals 5 4 equals 6 2 5. Large diamond 3, power of a power rule. AMN equals AM dot operator N, AMN equals AM dot operator N. Check mark multiply the powers when raising a power to another power. Small diamond example. 3 2 4 equals 3 2 dot operator 4 equals 3 8 equals 6561. 3 2 4 equals 3 2 dot operator 4 equals 3 8 equals 6561. Large diamond 4, power of a product rule. ABM equals AM dot operator BM AB M equals AM dot operator BM. Check mark distribute the exponent to each factor. Small diamond example. 2 dot operator 5 3 equals 2 3 dot operator 5 3 equals 8 dot operator 125 equals 1002 dot operator 5 3 equals 2 3 dot operator 5 3 equals 8 dot operator 125 equals 1000. Large diamond 5, power of a quotient rule. ABM equals AM BM, B does not equal 0, BAM equals BM. AM B equals 0. Small diamond example. 3 2 2 equals 3 2 2 2 equals 9 4 2 3 2 equals 2 2. 3 2 equals 4 9. Large diamond 6, 0 exponent rule. 0 equals 1, a does not equal 0, a 0 equals 1, a equals 0. Check mark any non-zero number raised to the power 0 is 1. Small diamond example. 7 equals 1, minus 5 0 equals 1 7 0. Equals 1, minus 5, 0. Equals 1. Large diamond 7, negative exponent rule. Minus n equals 1 a n a does not equal 0, a minus n equals a n. 1 a equals 0. Check mark a negative exponent means reciprocal. Small diamond example. 2 minus 3 equals 1, 2 3 equals 1, 8 2 minus 3 equals 2 3. 1 equals 8 1. Large diamond 8, fractional exponent rule. Mn equals a m n equals a n m a n m. Equals n. A m. Equals n. A m. Check mark a fractional exponent means a root. Small diamond example. 8 and a third equals 8 3 equals 2 and 16 and 3 quarters equals 16 4 3 equals 2 3 equals 8 8 and a third equals 3. 8 equals 2 and 16 and 3 quarters. Equals 4. 16 3 equals 2 3 equals 8. Large diamond summary of all laws. M dot operator a n equals a m plus n a m dot operator a n equals a m plus n. A m a n equals a m minus n a n. A m equals a m minus n. A m n equals a m n a m n equals m n. A b m equals a m dot operator b m ab m. Equals a m dot operator b m. A b m equals a m b m b a m equals b m. A m. A 0 equals 1 a does not equal 0 a 0. Equals 1 a. Equals 0. A minus n equals 1 a n a minus n equals a n. 1. A m n equals a m n a m n equals n. A m. Memo practice questions. Simplify. 2. 4 dot operator 2 minus 2 equals. 2 4 dot operator 2 minus 2 equals. Check mark answer. 2. 4 minus 2 equals 2 2 equals 4 2 4 minus 2 equals 2 2 equals 4. Evaluate. 5 2 3 equals. 2 5 3 equals. Check mark answer. 5. 3 2 3 equals 1 2 5 8 2 3. 5 3. Equals 8,125. Simplify. 9. Minus 1 half equals. 9. Minus 1 half equals. Check mark answer. 1. 9 equals 1 3 9. 1 equals 3 1. Would you like 20 MCQs with solutions based on laws of exponents? You said. Basic number properties commutative, associative, distributive laws ChatGPT said. Blue circle basic number properties. Commutative, associative, and distributive laws. Full explanation. Understanding number properties is essential in arithmetic and algebra for simplifying expressions and solving equations efficiently. These properties apply mainly to addition and multiplication. Large diamond 1. Commutative property. Pushpin the order of numbers can be changed without affecting the result. Check mark for addition. A. Plus b equals b plus a. A plus b equals b plus a. Check mark for multiplication. A. Times b equals b times a. A times b equals b times a. Cross mark does not apply to subtraction or division. Small diamond example addition. 4 plus 7 equals 7 plus 4 equals 11. 4 plus 7 equals 7 plus 4 equals 11. Small diamond example multiplication. 3 times 5 equals 5 times 3 equals 15. 3 times 5 equals 5 times 3 equals 15. Large diamond 2. Associative property. Pushpin when adding or multiplying more than two numbers, the grouping does not change the result. Check mark for addition. A plus b plus c equals 8. Pushpin when adding or multiplying more than two numbers, the grouping does not change the result. Check mark for addition. A plus b plus c equals a plus b plus c. A plus b plus c equals a plus b plus c. Check mark for multiplication. A times b times c equals a times b times c. A times b times c equals a times b times c. Cross mark does not apply to subtraction or division. Small diamond example addition. 2 plus 3 plus 4 equals 5 plus 4 equals 9 and 2 plus 3 plus 4 equals 2 plus 7 equals 9. 2 plus 3 plus 4 equals 5 plus 4 equals 9 and 2 plus 3 plus 4 equals 2 plus 7 equals 9. Small diamond example multiplication. 1 times 2 times 3 equals 2 times 3 equals 6 and 1 times 2 times 3 equals 1 times 6 equals 6. 1 times 2 times 3 equals 2 times 3 equals 6 and 1 times 2 times 3 equals 1 times 6 equals 6. Large diamond 3. Distributive property. Pushpin multiplication distributes over addition or subtraction. Check mark general form. A. Dot operator b plus c equals a dot operator b plus a dot operator c. A dot operator b plus c equals a dot operator b plus a dot operator c. A. Dot operator b minus c equals a dot operator b minus a dot operator c. A dot operator b minus c equals a dot operator b minus a dot operator c. Small diamond example. 3 dot operator 4 plus 5 equals 3 dot operator 9 equals 27 and 3 dot operator 4 plus 3 dot operator 5 equals 12 plus 15 equals 27. 3 dot operator 4 plus 5 equals 3 dot operator 9 equals 27 and 3 dot operator 4 plus 3 dot operator 5 equals 12 plus 15 equals 27. Small diamond example with subtraction. 6 dot operator 10 minus 3 equals 6 dot operator 7 equals 42 and 6 dot operator 10 minus 6 dot operator 3 equals 60 minus 18 equals 42. 6 dot operator 10 minus 3 equals 6 dot operator 7 equals 42 and 6 dot operator 10 minus 6 dot operator 3 equals 60 minus 18 equals 42. Green square summary table. In words only commutative law. Order doesn't matter applies to plus and times. Associative law. Grouping doesn't matter applies to plus and times. Distributive law. Multiply over addition subtraction. Large diamond quick practice. Which property is used in 5? Plus 3 equals 3 plus 5. 5 plus 3 equals 3 plus 5. Check mark commutative property of addition. Which property is used in 2? Dot operator 4 plus 6 equals 2 dot operator 4 plus 2 dot operator 6. 2 dot operator 4 plus 6 equals 2 dot operator 4 plus 2 dot operator 6. Check mark distributive property. Which property is used in 7 plus 2 plus 5 equals 7 plus 2 plus 5. 7 plus 2 plus 5 equals 7 plus 2 plus 5. Check mark associative property of addition. Would you like 10 MCQs with explanations based on these properties? You said. Simplification and approximation square roots and cube roots ChatGPT said. Blue circle simplification and approximation square roots and cube roots. These are essential topics in SSC, railway, banking, and other competitive exams. Let's cover each in full detail. Large diamond 1. Simplification and approximation. Simplification means reducing a numerical expression to its simplest form using BODMAS, surds, fractions, and percentage logic. Approximation means estimating values to solve quickly when exact answers are not required. Check mark common tricks. Use nearest round figures for approximation. Avoid unnecessary decimals. Keep it simple. Use BODMAS for simplification. Round off large numbers smartly. Example, 398 approximately equals 400, 51 approximately equals 50. Large diamond example 1 simplification. 48 divided by 4 plus 3 times 5 equals. 48 divided by 4 plus 3 times 5 equals. Small diamond step 1 48. Divided by 4 equals 12. 48 divided by 4 equals 12. Small diamond step 2 3. Times 5 equals 15. 3 times 5 equals 15. Small diamond step 3 12. Plus 15 equals 27. 12 plus 15 equals 27. Check mark answer 27. Large diamond example 2 approximation. 198 times 51 divided by 49 approximately equals. 198 times 51 divided by 49 approximately equals. Small diamond approximate. 198 approximately equals 200. 51 approximately equals 50. 49 approximately equals 50. So, 200 times 50 divided by 50 equals. 10,050 equals 200. 200 times 50 divided by 50 equals 50. 10,000 equals 200. Checkmark approximate answer, 200. Large diamond 2, square root checkmark square root means a number which, when multiplied by itself, gives the original number. 36 equals 6. Because 6 times 6 equals 36, 36. Equals 6 because 6 times 6 equals 36. Large diamond important square numbers, 1 to 21. 2 equals 1. 2 2 equals 4. 3 2 equals 9. 4 2 equals 16. 5 2 equals 25. 22 equals 400, 1 2. Equals 1, 2 2. Equals 4, 3 2. Equals 9, 4 2. Equals 16, 5 2. Equals 25, 22. Equals 400. Large diamond shortcuts, last digit trick. If a number ends in 2, 3, 7, or 8 right pointing arrow not a perfect square. Example, 122 ends in 2 right pointing arrow not a perfect square. Estimation. 52 52. Is between 49. Equals 7 49. Equals 7 and 64. Equals 8 64 equals 8. So, 52 approximately equals 7.252. Approximately equals 7.2. Large diamond 3, cube roots checkmark cube root means a number which, when multiplied by itself 3 times, gives the original number. 27 3 equals 3. Because 3 times 3 times 3 equals 27 3. 27 equals 3 because 3 times 3 times 3 equals 27. Large diamond important cube numbers 1 to 12 1. 3 equals 1. 2 3 equals 8. 3 3 equals 27. 4 3 equals 64. 5 3 equals 125. 12 3 equals 17 28 1. 3 equals 1 2 3 equals 8 3 3 equals 27 4 3 equals 64 5 3 equals 125 12 3 equals 17 28. Large diamond cube root estimation trick. For example, 729 3 equals try 9. 3 equals 729 right words double arrow 9 3. 729 equals try 9 3 equals 729 right words double arrow 9. If not perfect, guess between two cubes. 503 approximately equals 8. Since 8. 3 equals 512. 7 3 equals 343 3. 500 approximately equals 8 since 8 3 equals 512 7 3 equals 343. Large diamond rationalization example 1. 5 plus 3 right words double arrow. Multiply with conjugate 5. Minus 3 5 minus 3 right words double arrow 5 minus 3 5 minus 3 equals 5 minus 3 2 5 plus 3. 1. Right words double arrow multiply with conjugate 5. Minus 3. 5 minus 3. Right words double arrow 5 minus 3 5 minus 3 equals 2 5 minus 3. Checkmark final answer 5. Minus 3 2 2 5 minus 3. Green square practice MCQs. What is the value of 144? 144. A 10B. 11C. 12D. 13 checkmark answer. C12. Find 1003. 3. 1000. A 10B. 100C. 20D. 30 checkmark answer. A 10. Approximate. 402. Times 51 divided by 49 approximately equals 402 times 51 divided by 49 approximately equals A 400B. 420C. 425D. 410 checkmark approximate is 400. Times 50 divided by 50 equals 400. 400 times 50 divided by 50 equals 400 checkmark answer. A 400. Would you like 15 practice questions with solutions for this topic next? You said. Decimal and fraction operations. ChatGPT said. Blue circle decimal and fraction operations. Full concept explained. Decimals and fractions are two ways of representing numbers that are less than a whole. Understanding how to operate with them is essential in simplification, arithmetic, and word problems. Large diamond 1. Basics of decimals. A decimal number has a whole part and a fractional part separated by a dot called the decimal point. Example. 2.5 right pointing arrow 2 is a whole part. 5 is a tenth part. Checkmark types of decimal places. Tenth, 0.1. Hundredth, 0.01. Thousandth, 0.001. Each place is 10 times smaller than the one before. Large diamond decimal operations. Addition, subtraction. Line up the decimal points. Add or subtract like normal. Small diamond example. 3.45 plus 6.7 equals 3.45 plus 6.70 equals 10.15. 3.45 plus 6.7 equals 3.45 plus 6.70 equals 10.15 multiplication. Multiply without the decimal. Count total decimal places in both numbers and place the point accordingly. Small diamond example. 2.4 times 3.5 equals 24 times 35 equals 840 right pointing arrow 2 DCIMALPLACES right pointing arrow. 8.40. 2.4 times 3.5 equals 24 times 35 equals 840 right pointing arrow 2 decimal places right pointing arrow 8.40 division. Move the decimal point to make the divisor a whole number. Move the same number of places in the dividend. Small diamond example. 4.8 divided by 0.6 equals 48 divided by 6 equals 8. 4.8 divided by 0.6 equals 48 divided by 6 equals 8. Large diamond 2. Basics of fractions. A fraction is a number of the forma. BBA. Where A is the numerator part. B is the denominator pole. Checkmark types of fractions. Proper. 2. 552. Numerator and LT. Denominator. Improper. 7. 337. Numerator and GT. Denominator. Mixed. 2. 12221. A whole plus fraction. Large diamond fraction operations. Addition, subtraction. Make denominators common. LCM. Then add, subtract numerators. Small diamond example. 2 5 plus 1 3 equals 6 15 plus 5 15 equals 1 1 1 5 5 2 plus 3 1 equals 15 6 plus 15 5 equals 15 11. Multiplication. Multiply numerators together. Then denominators. Small diamond example. 2 3 times 5 7 equals 1 0 2 1 3 2 times 7 5 equals 21 10. Division. Multiply by the reciprocal of the second fraction. Small diamond example. 3 4 divided by 2 5 equals 3 4 times 5 2 equals 1 5 8 4 3 divided by 5 2 equals 4 3 times 2 5 equals 8 15. Large diamond 3. Decimal left right arrow fraction conversion checkmark decimal to fraction. Write the decimal over its place value and simplify. Small diamond example. 0.75 equals 75,100 equals 34. 0.75 equals 175 equals 43. Checkmark fraction to decimal. Divide numerator by denominator. Small diamond example. 3 5 equals 3 divided by 5 equals 0.653. Equals 3 divided by 5 equals 0.6. Large diamond 4. Comparison tips to compare decimals. Add trailing zeros if needed. 0.70 as 0.65 right pointing arrow. 0.70 in GT. 0.65. 0.70 as 0.65 right pointing arrow. 0.70 in GT. 0.65 to compare fractions. Convert to LCM or cross multiply. 340 as 2 3 right pointing arrow 3 times 3 equals 9. 4 times 2 equals 8 right words double arrow 3 4. And GT 2. 3 4 3 versus 3 2. Right pointing arrow 3 times 3 equals 9. 4 times 2 equals 8 right words double arrow 4. 3. and GT, 3. 2. Green square quick practice, 0.4. Plus. 0.75 equals. 0.4 plus 0.75 equals. Check mark answer, 1.15. 35 plus 2, 3 equals. 5, 3 plus 3, 2 equals. Check mark LCM equals 15 right words, double arrow 9. 15 plus 10, 15 equals 19, 15 equals 1, 4, 1. Mixed operations, fractions plus decimals plus percentages, ChatGPT said. Blue circle mixed operations, fractions plus decimals plus percentages. In competitive exams like SSC, railway, banking, etc., many questions involve mixed operations using fractions, decimals, and percentages. Mastering the conversion and interaction is crucial for simplification and word problems. Large diamond 1, essential conversions. Before performing mixed operations, always convert all terms to the same form, either decimal, fraction, or percentage, depending on the question. Repeat button common conversions. Fraction decimal percentage 1/2 0.5 50%. 1/4 0.25 25%, 3/4 0.75 75%, 1/5 0.2 20%, 3/5 0.6 60%, 2/3 0.666. 66.67%, 1/8 0.125 12.5%, 3/8 0.375 37.5%, 5/8 0.625 62.5%. Large diamond 2. Rules of mixed operations to simplify expressions with mixed forms. Convert everything to either decimal or fraction. Use BODMAS for order. Convert percentages to decimals. X% equals X 100, X% equals 100X. Large diamond example 1. Simplify. 1 2 plus. 0.25 plus. 30% to 1. Plus 0.25 plus 30%. Small diamond step 1. Convert all to decimals. 1 2 equals 0.5. 0.25 equals. 0.25. 30% equals. 0.302. 1. Equals 0.5. 0.25 equals 0.25. 30% equals 0.30. Small diamond step 2. Add them. 0.5 plus. 0.25 plus. 0.30 equals. 1.05. 0.5 plus 0.25 plus 0.30 equals 1.05. Check mark answer. 1.05. Large diamond example 2. Simplify. 75% plus 1 4 plus 0.5 equals. 75% plus 4. 1. Plus 0.5 equals. Small diamond convert. 75% equals 0.75. 1 4 equals. 0.254. 1. Equals 0.25. Small diamond total. 0.75 plus. 0.25 plus. 0.5 equals 1.5. 0.75 plus 0.25 plus 0.5 equals 1.5. Check mark answer. 1.5. Large diamond example 3. Fraction answer. What is? 2 pi plus 0.4 plus 20% 5 2. Plus 0.4 plus 20%. Small diamond convert all to fractions. 0.4 equals 2. 5 5 2. 20% equals 1. 5 5 1. So. 2 pi plus 2 pi plus 1 5 equals 5 5 equals 1. 5 2 plus 5 2 plus 5 1 equals 5 5 equals 1. Check mark answer. 1. Large diamond 3. Word problem example. Large diamond example 4. A man spends 1/4 of his salary on food, 35% on rent, and 0.15 on transport. What fraction of his salary is left? Small diamond convert all to fractions or decimals. 1 4 equals. 0.254. 1. Equals 0.25. 35% equals 0.35. 0.15 already decimal. Small diamond total spent equals 0.25. Plus. 0.35 plus. 0.15 equals. 0.75. 0.25 plus 0.35 plus 0.15 equals 0.75. Small diamond remaining equals 1. Minus. 0.75 equals. 0.25. 1 minus 0.75 equals 0.25 equals 1. 441. Check mark answer. 1. 441. Of salary is left. Green square practice MCQs. 3. 5 plus 0.2 plus 40% equals. 5 3. Plus 0.2 plus 40% equals. Check mark convert. 3 5 equals 0.653. Equals 0.6. 0.2 equals 0.2. 40% equals 0.4. Total equals 0.6 plus 0.2 plus 0.4 equals 1.2. 0.3 plus 25% plus 1 5 equals. 0.3 plus 25% plus 5. 1 equals. Check mark convert. 25% equals 0.25. 1 5 equals 0.251. Equals 0.2. Total equals 0.3 plus 0.25 plus 0.2 equals 0.75. Which of the following is equal to 0.625? A. 3443. B 5885. C 2332. D 4774. Check mark answer. B 5. 885. Would you like 15 practice word problems and MCQs with solutions based on mixed operations? You said. Use of approximation techniques. ChatGPT said. Blue circle use of approximation techniques. Full concept explained. Approximation is a method of simplifying complex calculations by rounding numbers to the nearest easy to handle values. This is especially useful in competitive exams like SSC, banking, railways, etc., where speed and accuracy are key. Large diamond Y use approximation. Check mark save time. Check mark quickly eliminate wrong options. Check mark useful when exact value isn't necessary. Check mark helps in mental math and estimation. Large diamond 1. Rounding numbers less than 5 right pointing arrow round down. 5 or more right pointing arrow round up. Small diamond examples. 47 approximately equals 50. 198 approximately equals 200. 349.5 approximately equals 350. 1.96 approximately equals 2.0. Large diamond 2. Approximating sums and differences. Add, subtract rounded values. Small diamond example. 49 plus 78 approximately equals 50 plus 80 equals 130. 49 plus 78 approximately equals 50 plus 80 equals 130. Small diamond example. 201 minus 98 approximately equals 200 minus 100 equals 100. 201 minus 98 approximately equals 200 minus 100 equals 100. Large diamond 3. Approximating multiplication round one or both numbers to nearest tens hundreds. Small diamond example. 198 times 51 approximately equals 200 times 50 equals 10,000. 198 times 51 approximately equals 200 times 50 equals 10,000. Small diamond example. 9.8 times 4.1 approximately equals 10 times 4 equals 40. 9.8 times 4.1 approximately equals 10 times 4 equals 40. Large diamond 4. Approximating division round numbers to easy values that divide well. Small diamond example. 402 divided by 49 approximately equals 400 divided by 50 equals 8. 402 divided by 49 approximately equals 400 divided by 50 equals 8. Small diamond example. 96 divided by 11 approximately equals 100 divided by 10 equals 10. 96 divided by 11 approximately equals 100 divided by 10 equals 10. Large diamond 5. Using approximation and percentages. Convert percentages to nearby easy values. Small diamond example. 18% of 198 approximately equals 20% of 200 equals 40. 18% of 198 approximately equals 20% of 200 equals 40. Large diamond 6. Square root and cube root approximation. Use nearby perfect squares or cubes. Small diamond example. 50 approximately equals 7.1. Since 49 equals 750. Approximately equals 7.1 since 49. Equals 7. Small diamond example. 63 approximately equals 3.9. Since 64 3 equals 4 3. 60. Approximately equals 3.9 since 3. 64. Equals 4. Large diamond 7. Shortcut approximations 25% approximately equals 1 quarter. 33.33% approximately equals 1 third. 50% equals 1 half. 66.67% approximately equals 2 thirds. 75% equals 3 quarters. These help in quick percentage problems. Green square practice examples. 399. Plus 215 approximately equals. 399 plus 215 approximately equals. Check mark. 400 plus 215 equals 615. 400 plus 215 equals 615. 29.9 times. 4.1 approximately equals. 29.9 times 4.1 approximately equals. Check mark. 30 times 4 equals 120. 30 times 4 equals 120. 82 approximately equals. 82 approximately equals. Check mark between 81. Equals 981. Equals 9 and 100 equals 10,100. Equals 10. So approximately equals 9.05. Approximate 22%. 22% of 98. Check mark. 22% approximately equals 20%. 22% approximately equals 20%. 98 approximately equals 100 right pointing arrow. 20%. 20% of 100 equals 20. Memo tips for using approximation. Use only when options are far apart. If options are close like 237, 238, 239, use exact method. Prefer rounding to nearest 10, 100, or 1000 for simplicity. Would you like 15 MCQs based on approximation techniques for practice? You said. Short tricks using Vedic math if applicable. Small diamond algebra. Basic algebraic identities. A plus b squared. A squared minus b squared. X plus a x plus b, etc. ChatGPT said. Blue circle Vedic math short tricks. Basic algebra and identities. Vedic math provides fast and intuitive techniques to solve algebraic expressions, factorization, and expansions, especially using algebraic identities. These help you calculate faster in SSC, railway, banking, and other aptitude exams. Large diamond 1. Basic algebraic identities. Must know check mark identity 1. A plus b2 equals a 2 plus 2 ab plus b2. A plus b2 equals a 2 plus 2 ab plus b2. Small diamond example. 12 plus 3 2 equals 12 2 plus 2 dot operator 12 dot operator 3 plus 3 2 equals 144 plus 72 plus 9 equals 225 12 plus 3 2 equals 12 2 plus 2 dot operator 12 dot operator 3 plus 3 2 equals 144 plus 72 plus 9 equals 225 check mark identity 2. A minus b2 equals a 2 minus 2 ab plus b2. A minus b2 equals a 2 minus 2 ab plus b2. Small diamond example. 15 minus 5 2 equals 15 2 minus 2 dot operator 15 dot operator 5 plus 5 2 equals 225 minus 150 plus 25 equals 115 minus 5 2 equals 15 2 minus 2 dot operator 15 dot operator 5 plus 5 2 equals 225 minus 150 plus 25 equals 100 check mark identity 3. 2 minus b2 equals a plus b a minus b a 2 minus b2 equals a plus b a minus b. Small diamond example. 49 minus 36 equals 7 plus 6 7 minus 6 equals 13 dot operator 1 equals 13. 49 minus 36 equals 7 plus 6 7 minus 6 equals 13 dot operator 1 equals 13 check mark identity 4. X plus a x plus b equals x2 plus a plus b x plus ab. X plus a x plus b equals x2 plus a plus b x plus ab. Small diamond example. X plus 3 x plus 5 equals x2 plus a x plus 15. X plus 3 x plus 5 equals x2 plus 8 x plus 15. Check mark identity 5 special Vedic form. A plus b 3 equals a 3 plus b 3 plus 3 ab a plus b. A plus b 3 equals a 3 plus b 3 plus 3 ab a plus b. Small diamond example. 2 plus 1 3 equals 8 plus 1 plus 3 dot operator 2 dot operator 1 dot operator 3 equals 9 plus 18 equals 27. 2 plus 1 3 equals 8 plus 1 plus 3 dot operator 2 dot operator 1 dot operator 3 equals 9 plus 18 equals 27. Large diamond 2. Vedic math speed tricks for algebra. Large diamond a plus b squared using Vedic trick. Small diamond example. 104. 2 equals 104 2 equals. Take 100 as base. Let equals 100. B equals 4. A equals 100. B equals 4 use. 100 plus 4 2 equals 100 2 plus 2 dot operator 100 dot operator 4 plus 4 2 equals. 10,000 plus. 800 plus 16 equals. 10,816. 100 plus 4 2 equals 102. Plus large diamond 1. Basic algebraic identities. Must know check mark identity 1. A plus b2 equals a 2 plus 2 ab plus b2. A plus b2 equals a 2 plus 2 ab plus b2. Small diamond example. 12 plus equals 144 plus 72 plus 9 equals 225 check mark identity 2. A minus b2 equals a 2 minus 2 ab plus b2. A minus b2 equals a 2 minus 2 ab plus b2. Small diamond example. 2 minus b2 equals a plus b a minus equals 225 minus 150 plus 25 equals 100 check mark identity 3. 2 minus b2 equals a plus b a minus b a 2 minus b2 equals a plus b a minus b. Small diamond example. 49 minus 36 equals 7 plus 6 7 minus 6 equals 13 dot operator 1 equals 13. 49 minus 36 equals 7 plus 6 7 minus 6 equals 13 dot operator 1 equals 13 check mark identity 4. X plus a x plus b equals x2 plus a plus b x plus ab. X plus a x plus b equals x2 plus a plus b x plus ab. Small diamond example. X plus 3 x plus 5 equals x2 plus 8 x plus 15. X plus 3 x plus 5 equals x2 plus 8 x plus 15. Check mark identity 5 special Vedic form. A plus b 3 equals a 3 plus b 3 plus 3 ab a plus b. A plus b 3 equals a 3 plus b 3 plus 3 ab a plus b. Small diamond example. 2 plus 1 3 equals 8 plus 1 plus 3 dot operator 2 dot operator 1 dot operator 3 equals 9 plus 18 equals 27. 2 plus 1 3 Equals 8 plus 1 plus 3 dot operator 2 dot operator 1 dot operator 3 equals 9 plus 18 equals 27 large diamond 2. Vedic math speed tricks for algebra large diamond 8 plus b squared using Vedic trick. Small diamond example. 104. 2 equals 104 2 equals. Take 100 as base. Let it equals 100. B equals 4. A equals 100. B equals 4 use. 100 plus 4 2 equals 100 2 plus 2 dot operator 100 dot operator 4 plus 4 2 equals. 10,000 plus. 800 plus 16 equals. 10,816 100 plus 4 2. Equals 102. Plus 2 dot operator 100 dot operator 4 plus 4 2. Equals 10,000 plus 800 plus 16 equals 10,816. Checkmark trick. Use base plus or minus deviation from 100. Large diamond A, B A plus B equals A squared minus B squared. Right pointing arrow difference of squares. Small diamond example. 102 dot operator 98 equals 100 plus 2. 100 minus 2 equals 102 minus 2 2 equals. 10,000 minus 4 equals 9,996. 102 dot operator 98 equals 100 plus 2. 100 minus 2 equals 102. Minus 2 2. Equals 10,000 minus 4 equals 9,996. Large diamond Vedic pattern. Multiply numbers close to 100 example. 97 dot operator 96. 97 dot operator 96. Step 1. Base equals 100. Step 2. 97 is 3 less than 100. 96 is 4 less than 100. Step 3. Left part equals 97. Minus 4 equals 93. 97 minus 4 equals 93. Right part equals 3. Dot operator 4 equals 12. 3 dot operator 4 equals 12. Final answer. 9,312. Checkmark 97 times 96 equals 9,312. Large diamond 3. Shortcut factorization using identity factor. X. 2 plus 9x plus 20 x2. Plus 9x plus 20. Try to write 9 as sum of two numbers whose product is 20. Small diamond 4 plus 5 equals 9 and 4 times 5 equals 20 so. x2 plus 9x plus 20 equals x plus 4 x plus 5 x2. Plus 9x plus 2 equals x plus 4 x plus 5. Checkmark done by identity. X plus a x plus b equals x2 plus a plus b x plus ab. X plus a x plus b equals x2. Plus a plus b x plus ab green square practice questions. Expand. A plus 6 2. A plus 6 2. Checkmark answer. 2 plus 12 a plus 36 is 2. Plus 12 a plus 36. Factorize. X. 2 plus 7 x plus 10 x2. Plus 7 x plus 1 no checkmark answer. X plus 2 x plus 5. X plus 2 x plus 5. Simplify using identity. 54 2 minus 4 6 2 equals. 5 4 2. Minus 4 6 2. Equals. Checkmark use a 2 minus b2 equals a plus b a minus b a2 minus b2. Equals a plus b a minus b. 54 plus 46. 54 minus 46 equals 100 dot operator 8 equals 800. 54 plus 46. 54 minus 46 equals 100 dot operator 8 equals 800. Would you like 20 MCQs and word problems based on algebraic identities using Vedic tricks for practice? You said. Factorization of algebraic expressions. ChatGPT said. Blue circle factorization of algebraic expressions. Full concept explained. Factorization means expressing an algebraic expression as a product of its factors. It's a core algebra skill used in simplifying, solving equations, and pattern recognition in competitive exams like SSC, railway, banking, etc. Large diamond 1. What is factorization? To factorize an algebraic expression means to write it as a product of simpler expressions, factors, such that when multiplied, they give back the original expression. Small diamond example. x2 plus 5x plus 6 equals x plus 2 x plus 3 x2. Plus 5x plus 6 equals x plus 2 x plus 3. Large diamond 2. Methods of factorization. Checkmark. I common factor. Method factor of the common term from all parts. Small diamond example. 2x2 plus 4x equals 2x x plus 2 2x2. Plus 4x equals 2x x plus 2. Checkmark 2. Using algebraic identities apply known identities. A 2 minus b2 equals a minus b a plus b a2 minus b2. Equals a minus b a plus b. A plus b2 equals a 2 plus 2 ab plus b2. A plus b2. Equals a 2. Plus 2 ab plus b2. A minus b2 equals a 2 minus 2 ab plus b2. A minus b2. Equals a 2. Minus 2 ab plus b2. x2 plus a plus b x plus ab equals x plus a x plus b x2. Plus a plus b x plus ab equals x plus a x plus b. Small diamond example. x2 minus 9 equals x minus 3 x plus 3 x2. Minus 9 equals x minus 3 x plus 3. Checkmark 3. Splitting the middle term. Quadratic trinomials. Factor expressions like x. 2 plus bx plus cx2. Plus bx plus c by splitting the middle term. Small diamond example. Factorize x. 2 plus 7x plus 10x2. Plus 7x plus 10. Step 1. Find two numbers that add to 7 and multiply to 10. Right pointing arrow 2 and 5. Step 2. x2 plus 2x plus 5x plus 10 equals x plus 2 plus 5x plus 2 equals x plus 2 x plus 5 x2. Plus 2x plus 5x plus 1 equals x plus 2 plus 5x plus 2 equals x plus 2 x plus 5. Checkmark final answer. X plus 2 x plus 5. X plus 2 x plus 5. Checkmark ID. Grouping method used when there are 4 or more terms. Small diamond example. Factorize. X plus ay plus bx plus by. X plus I plus bx plus y. Group terms. Ax plus ay plus bx plus by equals ax plus y plus bx plus y equals a plus bx plus y. X plus I plus bx plus y equals ax plus y plus bx plus y equals a plus bx plus y. Checkmark B. Factorizing cubic expressions use special formulas. A 3 plus b3 equals a plus b a2 minus ab plus b2. A 3 plus b3 equals a plus b a2 minus ab plus b2. A 3 minus b3 equals a minus b a2 plus ab plus b2. A 3 minus b3 equals a minus b a2 plus ab plus b2. Small diamond example. x3 plus 27 equals x3 plus 3 3 equals x plus 3 x2 minus 3 x plus 9 x3 plus 27 equals x3 plus 3 3 equals x plus 3 x2 minus 3 x plus 9. Large diamond 3. Important tips. Always take out common factors first before applying identities. If it's a quadratic expression, try splitting the middle term. For 4 terms, always try grouping. Recognize patterns in cubes, squares, and identities. Green square practice questions. Factorize. X. 2 plus 11x plus 30x2. Plus 11x plus 3o. Checkmark 6 plus 5 equals 11 and 6 times 5 equals 30. Checkmark answer. X plus 6 x plus 5. X plus 6 x plus 5. Factorize. 4. x2 minus 25 4x2. Minus 25. Checkmark it is a difference of squares. 2x2 minus 5 2 equals 2x minus 5 2x plus 5. 2x2 minus 5 2 equals 2x minus 5 2x plus 5. Factorize. 2. x2 plus 7x plus 3 2x2. Plus 7x plus 3. Checkmark multiply 2 times 3 equals 6. Find two numbers that add to 7 and multiply to 6. 6 and 1 checkmark rewrite. 2. X2 plus 6x plus 3 equals 2x plus 3 plus 1x plus 3 equals 2x plus 1x plus 3 2x2. Plus 6x plus 3 equals 2x plus 3 plus 1x plus 3 equals 2x plus 1x plus 3. Would you like 20 factorization practice MCQs with solutions? You said. Linear equations in 1 and 2 variables ChatGPT said. Blue circle linear equations in 1 and 2 variables. Full concept explained. Linear equations are fundamental algebraic expressions where the variables have only power 1. These form the basis for solving real-life problems in SSC, railway, and banking exams. Large diamond 1. Linear equations in one variable. A linear equation in one variable is an equation of the form ax plus b equals 0. Where a does not equal 0. X plus b equals 0. Where a equals 0. It has only one unknown and one solution. Checkmark steps to solve. Simplify both sides. Remove brackets. Combine like terms. Bring variables to one side. Constants to the other. Divide to isolate the variable. Large diamond example 1. Solve. 5x minus 7 equals 3x plus 1. 5x minus 7 equals 3x plus 1. Step 1. Bring like terms together. 5x minus 3x equals 1 plus 7 right words double arrow 2x equals 8 right words double arrow x equals 8 2 equals 4. 5x minus 3x equals 1 plus 7 right words double arrow 2x equals 8 right words double arrow x equals 2. 8 equals 4. Checkmark answer. X equals 4. Large diamond example 2. Fractional coefficients solve. 2x3 minus 1 equals x2 plus 5 3 2x. Minus 1 equals 2. X plus 5. Multiply entire equation by LCM 6. 6 2x3 minus 1 equals 6 x2 plus 5 right words double arrow 4x minus 6 equals 3x plus 30 right words double arrow 4x minus 3x equals 30 plus 6 right words double arrow x equals 36 6 3 2x. Minus 1 equals 6 2. X. Plus 5 right words double arrow 4x minus 6 equals 3x plus 3 right words double arrow 4x minus 3x equals 30 plus 6 right words double arrow x equals 36 checkmark answer. X equals 36. Large diamond 2. Linear equations in two variables. A linear equation in two variables is of the form ax plus by equals c. Where a b does not equal 0. X plus y equals c. Where a b equals 0. It has infinitely many solutions unless another equation is given to form a system of equations. Large diamond 3. Solving two equations in two variables. Checkmark methods. Substitution method. Elimination method. Cross multiplication for MCQs. Large diamond example substitution solve. X plus y equals 10 1 x minus y equals 2 2. X plus y equals 10 1 x minus y equals 2 2 from 1. X equals 10 minus y. X equals 10 minus y. Substitute in 2. 10 minus y equals 2 right words double arrow 10 minus 2y equals 2 right words double arrow 2y equals 8 right words double arrow y equals 4. 10 minus y equals 2 right words double arrow 10 minus 2y equals 2 right words double arrow 2y equals 8 right words double arrow y equals 4 now. X equals 10 minus 4 equals 6. X equals 10 minus 4 equals 6. Checkmark answer. X equals 6. Y equals 4. Large diamond example elimination 3. X plus 2y equals 1 6 1 2x plus 3y equals 17 2. 3x plus 2y equals 16 1 2x plus 3y equals 17 2 multiply 1 by 3 and 2 by 2. 9x plus 6y equals 48 1 foot 4. X plus 6y equals 34 2 feet. 9x plus 6y equals 48 1 foot 4x plus 6y equals 34 2 feet subtract. 9x minus 4x equals 48 minus 34 right words double arrow 5x equals 14 right words double arrow x equals 14 5. 9x minus 4x equals 48 minus 34 right words double arrow 5x equals 14 right words double arrow x equals 5. 14. Now substitute into 1. 3 dot operator 14 5 plus 2y equals 16 right words double arrow 42 5 plus 2y equals 16 right words double arrow 2y equals 16 minus 42 5 equals 80 minus 42 5 equals 38 5 right words double arrow y equals 19 5 3 dot operator 5 14. Plus 2y equals 16 right words double arrow 5. 42. Plus 2y equals 16 right words double arrow 2y equals 16 minus 5. 42 equals 5. 80 minus 42. Equals 5 38. Right words double arrow y equals 5. 19. Checkmark answer. X equals 14 fifths. Y equals 19 fifths. Large diamond 4. Word problem example 1 variable q. A number increased by 5 is equal to 3 times itself. Find the number. Let number be x. X. X plus 5 equals 3x right words double arrow 5 equals 2x right words double arrow x equals 5 2. X plus 5 equals 3x right words double arrow 5 equals 2x right words double arrow x equals 2. 5. Checkmark answer. 5. 2 2 5. Green square practice MCQs. Solve. 3. X plus 4 equals 19. 3x plus 4 equals 1 9. A 5b. 4c. 60. 3 checkmark. X equals 15 3 equals 5 x equals 3 15 equals 5. Solve. 2. X plus 3y equals 12. X plus y equals 5. 2x plus 3y equals 12. X plus y equals 5 checkmark from 2x. Equals 5 minus y x equals 5 minus y substitute. 2. 5 minus y plus 3y equals 12 right words double arrow 10 minus 2y plus 3y equals 12 right words double arrow y equals 2. 2 5 minus y plus 3y equals 12 right words double arrow 10 minus 2y plus 3y equals 12 right words double arrow y equals 2. X. Equals 3x equals 3. If 5 times a number is 4 more than twice the number, find it. Let. X 5x equals 2x plus 4 right words double arrow 3x equals 4 right words double arrow x equals 4 3. 5x equals 2x plus 4 right words double arrow 3x equals 4 right words double arrow x equals 3. 4. Would you like 20 linear equation MCQs, both 1 and 2 variable with full solutions for practice? You said quadratic equation simplification of algebraic fractions. ChatGPT said. Blue circle quadratic equations and simplification of algebraic fractions. Full concept explained. These two topics are crucial in algebra and frequently appear in SSC, railway, banking, and other aptitude-based exams. Below is a complete breakdown with tricks, solved examples, and MCQs. Large diamond Carta. Quadratic equations checkmark definition. A quadratic equation is any equation of the form ax2 plus bx plus c equals 0. A does not equal 0. x2 plus bx plus c equals 0. A equals 0 where x is a variable. A, b, c. A, b, c are constants. Large diamond 1. Solving quadratic equations. Large diamond method 1. Factorization. Try to split the middle term. Small diamond example. x2 plus 7x plus 12 equals 0 right words double arrow x plus 3 x plus 4 equals 0 right words double arrow x equals minus 3. Minus 4 x2. Plus 7x plus 1 2 equals 0 right words double arrow x plus 3 x plus 4 equals 0 right words double arrow x equals minus 3. Minus 4 large diamond method 2. Quadratic formula x. Equals minus b plus or minus b2 minus 4 ac 2 a x equals 2b minus b plus or minus b2. Minus 4 ac. Small diamond example. Solve 2. x2 plus 3x minus 5 equals 0 to x2. Plus 3x minus 5 equals 0. Step 1. A. Equals 2. B equals 3. C equals minus 5. A equals 2. B equals 3. C equals minus 5. Step 2. X equals minus 3 plus or minus 3 2 minus 4 dot operator 2 dot operator. Large diamond method 3. Completing the square used when factorization is hard. Large diamond 2. Discriminant D and nature of roots D. Equals B2 minus 4 AC D equals B2. Minus 4 AC of D and GT, 0. D and GT, 0 right pointing arrow 2 real and distinct roots. If D equals 0. D equals 0 right pointing arrow 2 real and equal roots. If D and LT, 0. D and LT, 0 right pointing arrow complex roots, no real solution. Green square quadratic equation MCQs, solve. X. 2 minus 11x plus 30 equals 0 x2. Minus 11x plus 3 equals O. Checkmark factor, x5 x6 right pointing arrow x equals 5, 6. Find the nature of roots for 3. x2 plus 2x plus 7 equals 0 3 x2. Plus 2x plus 7 equals OD. Equals 4 minus 84 equals minus 80. D equals 4 minus 84 equals minus 80 right pointing arrow imaginary roots. Solve, x. 2 minus 6x equals 0 x2. Minus 6x equals 0 checkmark. X minus 6 equals 0. X minus 6 equals 0 right pointing arrow x equals 0 or 6. Large diamond part B. Simplification of algebraic fractions are expressions of the form Px Qx. Qx Px. Where Px. Px and Q. X. Qx are algebraic expressions. Checkmark 1. Canceling common factors, factor numerator and denominator and cancel common terms. Small diamond example. x2 minus 9 x2 minus x minus 6 equals x minus 3 x plus 3 x minus 3 x plus 2 equals x plus 3 x plus 2 x2. Minus x minus 6x. 2 minus 9 equals x minus 3 x plus 2 x minus 3 x plus 3 equals x plus 2 x plus 3. Checkmark 2. Multiplying algebraic fractions, multiply numerators and denominators, cancel if possible. Small diamond example. x2 minus 1 x2 plus 2 x plus 1 dot operator x plus 1 x minus 1 equals x minus 1 x plus 2 x plus 1 x. Checkmark 3. Dividing algebraic fractions, multiply the first by the reciprocal of the second. Word problems based on algebra. ChatGPT said. Blue circle word problems based on algebra. Full concept plus solved examples. Word problems test your real-life interpretation of algebra. These are frequently asked in SSC, railway, banking, and other aptitude exams. To solve them efficiently, convert statements into algebraic equations, then solve using standard algebra techniques. Large diamond 1. General strategy to solve word problems. Checkmark step 1. Let the unknown quantity be a variable, usually x. Checkmark step 2. Translate the statements into an algebraic equation. Checkmark step 3. Solve the equation using algebraic methods. Checkmark step 4. Verify the result and write the final answer. Large diamond 2. Common types of word problems. Large diamond type 1. H problem. Small diamond example 1. 5 years ago, O was twice as old as B. The sum of their present ages is 40. Find their ages. Let present age of A equals x. X. Then B equals 40. Minus x 40 minus x. 5 years ago. A equals x minus 5 x minus 5. B equals 40 minus x minus 5 equals 35 minus x. 40 minus x minus 5 equals 35 minus x. Given. X minus 5 equals 2. 35 minus x. Right words double arrow x minus 5 equals 70 minus 2x. Right words double arrow 3x equals 75. Right words double arrow x equals 25. X minus 5 equals 2. 35 minus x. Right words double arrow x minus 5 equals 70 minus 2x. Right words double arrow 3x equals 75. Right words double arrow x equals 25. Checkmark 8 equals 25. B equals 15. Large diamond type 2. Number problem. Small diamond example 2. A number exceeds its double by 10. Find the number. Let the number be x. X. Then. X equals 2x minus 10. Right words double arrow x equals 10. X equals 2x minus 10. Right words double arrow x equals 10. Checkmark answer. 10. Large diamond type 3. Work in time using linear equations. Small diamond example 3. A can do a job in 10 days. B in 15 days. How long will they take together? Let total work equals LCM 10. 15 equals 30 units. A's rate equals 3 units per day. B's rate equals 2 units per day. Together equals 5 units per day. Time equals 30. Divided by 5 equals 6. 30 divided by 5 equals 6 days. Checkmark answer. 6 days. Large diamond type 4. Mixture problem. Small diamond example 4. A solution contains milk and water in the ratio 3, 1. If the total quantity is 32 L, how much water is there? Ratio total equals 3 plus 1 equals 4 parts water equals 1. 4 times 32 equals 8 4 1. Times 32 equals 8 L. Checkmark answer. 8 liters. Large diamond type 5. Speed. Distance and time. Small diamond example 5. A car travels 60 kilometers at speed x. By kilometer per hour, then 90 kilometers at speed x. Plus 10. X plus 10 kilometers per hour. If the total time is 3 hours, find x. X. 60x plus 90x plus 10 equals 3x. 60 plus x plus 10. 9 equals 3. Multiply entire equation by x. X plus 10. X plus 10. 60x plus 10 plus 90. 60x plus 10. Minus. Solve using quadratic formula. Checkmark answer. X equals 45. X equals 45 kilometers per hour. Only positive root considered. Large diamond type 6. Geometry-based word problem. Small diamond example 6. The length of a rectangle is 5 more than its width. If the area is 84 square meters, find its dimensions. Let width equals x. X. So length equals x. Plus 5x plus 5. Area equals x. X plus 5 equals 84. X plus 5 equals 84. X2 plus 5x minus 84 equals 0. Right words double arrow. X plus 12. X minus 7 equals 0. Right words double arrow. X equals 7. Since x and GT, 0. X2. Plus 5x minus 84 equals 0. Right words double arrow. X plus 12. X minus 7 equals 0. Right words double arrow. X equals 7. Since x and GT, 0. Checkmark with equals 7 meters. Length equals 12 meters. Large diamond type 7. Money profit loss problem. Small diamond example 7. A shopkeeper gives a discount of 10% and still makes a profit of 8%. If the marked price is 250 rupees, find the cost price. Selling price equals 90% of 250 rupees equals 225 rupees. Let CP equals x. Profit equals 8%. 225 equals x plus 8,100 x equals x. 1.08. Right words double arrow. X equals 225. 1.08 equals rupee. 208.33. 225 equals x plus 108. X equals x. 1.08. Right words double arrow. X equals 1.08. 225 equals 208 rupees and 33 paise. Checkmark cost price equals 208 rupees and 33 paise. Green square quick practice MCQs. A number is such that its square is 12 more than 5 times the number. Find the number. X2 equals 5x plus 12. Right words double arrow. X2 minus 5x minus 12 equals 0. Right words double arrow. X equals 6 or minus 2. Right words double arrow. 6x2. Equals 5x plus 1 2 right words double arrow x2. Minus 5x minus 12 equals 0 right words double arrow x equals 6 or minus 2 right words double arrow 6. The sum of two numbers is 20. Their difference is 4. Find the numbers. Let one number equals x. X. Other equals 20. Minus x 20 minus x. X minus 20 minus x equals 4 right words double arrow 2x equals 24 right words double arrow x equals 12. 20 minus x equals 8 check mark ANSWER. 12 AND83. IF4 ISSUBTRACTEDFROM 3 TIMESANUMBER. THERESULTIS11. FINDTHENUMBER. 3x minus 4 equals 11 right words double arrow x equals 5. X minus 20 minus x equals 4 right words double arrow 2x equals 24 right words double arrow x equals 12. 20 minus x equals 8 check mark answer. 12 and 83. If 4 is subtracted from 3 times the number, their result is 11. Find the number. 3x minus 4 equals 11 right words double arrow x equals 5. Would you like 20 fully solved word problems with answers and explanations for practice? You said. Problems on ages using linear equations. Graphical representation basics. ChatGPT said. Blue circle problems on ages using linear equations and graphical representation basics. Full concept plus examples. These 2 topics are highly tested in SSC, railway, and other aptitude exams. Below is a full explanation of both sections with step-by-step logic, solved examples, and quick tricks. Large diamond parda. Problems on ages using linear equations. These problems involve comparing present, past, or future ages using simple linear equations. Usually, they involve one or two variables. Checkmark basic strategy. Assume present age of the person is x, y, etc. Translate statements into equations. Use past future condition. X years ago, right pointing arrow subtract. X years hence, right pointing arrow add. Solve using linear algebra. Large diamond example 1. The present age of A is twice that of B 5 years ago. The difference in their ages was 10 years. Find their present ages. Let B's present age equals x. X. Then A equals 2. X 2x. 5 years ago. A equals 2x minus 5. 2x minus 5. B equals x minus 5x minus 5. Given. 2x minus 5 minus x minus 5 equals 10 right words double arrow 2x minus 5 minus x plus 5 equals 10 right words double arrow x equals 10. 2x minus 5 minus x minus 5 equals 10 right words double arrow 2x minus 5 minus x plus 5 equals 10 right words double arrow x equals 10 check mark B equals 10 years. A equals 20 years. Large diamond example 2. The sum of the ages of the father and son is 60. After 5 years, the father's age will be 3 times the son's age. Find their present ages. Let son's age equals x. X, then father equals 60. Minus x 60 minus x. After 5 years, son equals x plus 5x plus 5. Father equals 60. Minus x plus 5 equals 65 minus x. 60 minus x plus 5 equals 65 minus x. Given. 65 minus x equals 3x plus 5. Right words double arrow 65 minus x equals 3x plus 15. Right words double arrow 65 minus 15 equals 4x. Right words double arrow x equals 12.5. 65 minus x equals 3x plus 5. Right words double arrow 65 minus x equals 3x plus 1 5. Right words double arrow 65 minus 15 equals 4x. Right words double arrow x equals 12.5. Check mark. Son equals 12.5 years. Father equals 47.5 years. Large diamond example 3. A's age is 3 times B's. After 6 years, A's age will be twice B's age. Find their present ages. Let B equals x. X. Then A equals 3. X 3x. After 6 years, A equals 3x plus 6. 3x plus 6. B equals x. Plus 6x plus 6. 3x plus 6 equals 2x plus 6. Right words double arrow 3x plus 6 equals 2x plus 12. Right words double arrow x equals 6. 3x plus 6 equals 2x plus 6. Right words double arrow 3x plus 6 equals 2x plus 1 2. Right words double arrow x equals 6. Check mark. B equals 6 years. A equals 18 years. Green square MCQ's ages. A is 4 years older than B after 6 years. The sum of their ages will be 40. Find B's current age. Let B equals x. X. Then equals x. Plus 4x plus 4. X plus 6 plus x plus 4 plus 6 equals 40. Right words double arrow 2x plus 16 equals 40. Right words double arrow x equals 12. X plus 6 plus x plus 4 plus 6 equals 40. Right words double arrow 2x plus 1 6 equals 40. Right words double arrow x equals 12. Check mark. B equals 12 years. A equals 16 years. Large diamond part B. Graphical representation basics. Graphs help in visualizing numerical data. You must know how to read and interpret the most common types of graphs. Check mark 1. Line graph shows trends over time. Points are connected by lines. Used for showing growth, decline, changes. Small diamond example. Population versus years. Check mark 2. Bar graph. Used for comparing different categories. Height or length of bars represents values. Can be vertical or horizontal. Small diamond example. Marks of students in different subjects. Check mark 3. Pie chart circle graph shows parts of a whole 100%. Each slice is a percentage. Useful in distribution questions. Small diamond example. Budget allocation. Population ratio. Check mark 4. Histogram. Special bar graph for frequency distribution. Bars touch each other. Used in statistics and data analysis. Check mark 5. XY graph Cartesian plane used for plotting equations like y equals mx plus c. X-axis horizontal, y-axis vertical. The intersection is the origin, 0, O. Large diamond important graphical interpretation skills. Know how to read scales. Understand axis labels. Interpret trends increasing, decreasing, constant. Calculate differences and averages from bars or points. Green square MCQs graphs. In a pie chart, if a sector represents 90 degrees, what percentage does it represent? 90. 360 times 100 equals 25%. 360 90. Times 100 equals 25%. If a bar graph shows sales of 10,000 rupees in January and 15,000 rupees in February, what's the percent increase? 5,000. 10,000 times 100 equals 50%. 100,000. Times 100 equals 50%. In a line graph, if the line slopes upward from left to right, the trend is check mark increasing. Would you like 20 practice problems on ages and graph interpretation, MCQs and word problems with full solutions? No file chosen, no file chosen. ChatGPT can make mistakes. Check important info. See cookie preference. Ratio and proportion. Theory lecture SSC level. The concept of ratio and proportion forms a foundational part of quantitative aptitude. Understanding these is crucial for solving a wide range of problems in competitive exams like SSC. Let us first understand what a ratio is. A ratio is a comparison of two quantities of the same kind and in the same unit. It tells us how many times one quantity is contained in another. The ratio of two numbers and B is written as A. B is read as A is to B. For example, if a person has 100 rupees and another person has 400 rupees, the ratio of their amounts is 1, 4, which means the second person has 4 times the money of the first person. The most important point in ratios is that both quantities must be of the same type and unit. We cannot compare 5 kilograms with 5 rupees or 3 meters with 3 seconds. Ratios can be simplified just like fractions. For instance, 20, 60 can be simplified by dividing both numbers by their highest common factor, which is 20. Hence, 20, 60 becomes 1, 3. Ratios are often used to compare two or more parts of a whole. For example, if in a class there are 10 boys and 20 girls, the ratio of boys to girls is 10-20, which simplifies to 1, 2. This means that for every 1 boy, there are 2 girls. Ratios can also be expressed as fractions. So, 2, 3 can also be written as 2/3. Now, let us understand the concept of proportion. Proportion is an equation that states that two ratios are equal. If A, B equals C, D, then A, B, C, and D are said to be in proportion. This is also written as A, B, C, D, and is read as A is to B as C is to D. In proportion, the product of the means B and C is equal to the product of the extremes A and D. That is, a times D equals B times circa. This property helps in solving many problems based on proportion. Types of variation are closely linked to proportion. The term variation refers to how one quantity changes in relation to another. There are three main types of variation: direct variation, inverse variation, and joint variation. In direct variation, two quantities increase or decrease together. That means, if one quantity increases, the other also increases in the same ratio. Mathematically, this is written as x proportional y, where y equals constant. For example, if you buy more apples, you pay more money. So, the number of apples and the total cost vary directly. In inverse variation, when one quantity increases, the other decreases in such a way that the product remains constant. That is, x proportional 1 y or x times y equals constant. A common example is speed and time. If you increase the speed of a vehicle, the time taken to cover the same distance decreases. If you reduce the speed, the time increases. The product speed times time remains constant for a fixed distance. Joint variation occurs when a quantity varies directly as one quantity and inversely as another at the same time. For example, the amount of work done can vary directly with the number of workers and inversely with the number of days taken. That means if you increase the number of workers, the time taken reduces, and if the number of workers decreases, the time taken increases. These concepts are the building blocks for solving complex arithmetic and joint variation occurs when a quantity varies directly as one quantity and inversely as another at the same time. For example, the amount of work done can vary directly with the number of workers and inversely with the number of days taken. That means if you increase the number of workers, the time taken reduces, and if the number of workers decreases, the time taken increases. These concepts are the building blocks for solving complex arithmetic and word problems. The key is to identify whether the problem is based on a ratio, a proportion, or a form of variation. Once that is clear, you can apply the correct mathematical principle to solve it quickly and accurately. Practice questions SSC previous year style. Question 1. If the ratio of the ages of two people is 4, 5 and the sum of their ages is 72 years, what is the age of the elder person? Solution. Let the ages be 4x and 5x. Then, 4x plus 5x equals 72, right pointing arrow 9x equals 72, right pointing arrow x equals the elder person's age equals 5x equals 5 times 8 equals 40 years. Question 2. A car travels at a speed which is inversely proportional to the time taken. If it covers a distance in 4 hours at 60 km per hour, how much time will it take if the speed is increased to 80 km per hour? Solution. Speed times time equals constant, right pointing arrow 60 times 4 equals 80 times t 240 equals 80t, right pointing arrow t equals 3 hours. Answer, 3 hours. Question 3. If 6 men can complete a work in 8 days, how many men are required to complete the same work in 4 days? Solution. Men proportional 1 days inverse variation, right pointing arrow 6 times 8 equals x times 4, right pointing arrow x equals 12. Answer, 12 men. Let me know the next topic you want. I'll continue with the same detailed paragraph style lecture format. You said. Continue proportions increase, decrease in ratios applications in real life problems. ChatGPT said. Here's the detailed SSC level theory lecture in pure paragraph format, continuing from the previous part and covering. Continue proportions. Increase, decrease in ratios. Applications in real life problems. Continue proportions. Continued proportion is a special case of proportion where three quantities are said to be in continued proportion if the first is to the second, if the second is to the third. In mathematical terms, if A, B equals B, C, then A, B, and C are said to be in continued proportion. The middle term B is called the mean proportional, and the third term C is the third proportional to A and B. From the definition, we can derive that B squared equals a times C, since in a proportion, the product of the means equals the product of the extremes. So if A, B equals B, C, then a times C equals B times B or B squared. This formula helps in quickly finding the missing term when two terms are known. For example, if A equals 2 and B equals 4, then C can be found by using the formula B squared equals a times C, right pointing arrow 16 equals 2 times C, right pointing arrow C equals 8. Thus, 2, 4 equals 4, 8, and 2, 4, 8 are in continued proportion. Continued proportion is often used in geometry and algebra problems, especially those involving similar triangles or scaling of quantities where a single ratio is extended over 3 terms. Increase and decrease in ratios. When one or both quantities in a ratio are increased or decreased, the ratio changes. Understanding how a change in the value of a term affects the overall ratio is important in many real-world problems. Let's explore how this works. If the original ratio is A, B, and A is increased by a certain percentage, then the new value becomes A plus a times percent increase 100. The same applies to a decrease. If both values change, then both are adjusted accordingly and a new ratio is formed. For example, if the ratio of two numbers is 3, 4, and the first number is increased by 50%, the new number becomes 3 plus 1.5 equals 4.5. So, the new ratio becomes 4.5, 4 and 9, 8 after simplifying. Similarly, if the second number is decreased by 25%, it becomes 4 to 1 equals 3, and the new ratio becomes 3, 3 equals 1, 1. This concept is important for solving percentage-based word problems, where we are asked to find the new ratio after an increase or decrease. The key step is to first apply the increase or decrease to the relevant term and then express both updated terms in a simplified ratio. Another important application is when we are required to find what percentage change in one quantity would equal a desired change in the ratio. In such problems, we must often work backward using proportion and percentage concepts. Applications in real life problems for solving percentage-based word problems, where we are asked to find the new ratio after an increase or decrease. The key step is to first apply the increase or decrease to the relevant term and then express both updated terms in a simplified ratio. Another important application is when we are required to find what percentage change in one quantity would equal a desired change in the ratio. In such problems, we must often work backward using proportion and percentage concepts. Applications in real life problems. The concepts of ratio and proportion are extremely useful in day-to-day life and in competitive exams. They are used in problems related to mixing, dividing amounts, comparing speeds, calculating costs, profit sharing, scaling of recipes, and interpreting maps. One common application is in partnership problems. Suppose 2 or more people invest money in a business for different durations. The profit or loss is shared in the ratio of their effective investments, calculated as the product of amount invested in time. For instance, if it invests rupee 3,000 for 4 months and B invests 6,000 rupees for 2 months, the profit will be divided in the ratio of 3,000 times 4, 6,000 times 2 equals 12,000, 12,000 equals 1, 1. Another practical use is in mixing problems, such as mixing milk and water or different grades of oils. If two substances are mixed in a certain ratio, and we are told the final quantity or cost, we can use ratio and proportion principles to find individual quantities or costs. For example, if 4 liters of milk is mixed with 6 liters of water, the ratio of milk to water is 4, 6 equals 2, 3. In problems of work and time, if two people work together, their efficiency is often compared in the form of a ratio. If A can do a piece of work in 5 days and B in 10 days, their work ratio is 1/5, 1/10 equals 2, 1. So it is twice as much work as B in the same time. Speed, distance, and time problems also rely on the concept of ratio. For example, if two cars travel the same distance but at different speeds, the time taken by each is inversely proportional to their speeds. So if car A and car B travel at 60 km per hour and 40 km per hour respectively, the time taken by A and B are in the ratio 2, 3. Another very useful area is recipe adjustments, where ingredients are scaled up or down maintaining their ratio. If a recipe requires ingredients in the ratio 2, 3, 5 and we are preparing for 10 people instead of 5, we double each quantity while keeping the ratio unchanged. In map reading, the scale uses a ratio. For example, a scale of 1, 100,000 means 1 centimeter on the map represents 100,000 centimeters or 1 kilometer on the ground. Thus, mastering ratio and proportion equips you to solve a wide range of SSC questions and also strengthens your practical math skills for everyday use. Practice questions SSC previous year style. Question 1. Find the third proportional to 4 and 6. Solution. Let the third proportional be x. Then, 4, 6 equals 6. X right pointing arrow 4 x equals 36 right pointing arrow x equals 9. Answer, 9. Question 2. The ratio of two numbers is 5, 6. If each number is increased by 4, the new ratio becomes 3, 4. What are the numbers? Solution. Let the numbers be 5x and 6x. Then, 5x plus 4, 6x plus 4 equals 3 quarters right pointing arrow cross multiply. 4 5x plus 4 equals 3, 6x plus 4 right pointing arrow 20x plus 16 equals 18x plus 12 right pointing arrow 2x equals minus 4 right pointing arrow x equals minus 2. This leads to negative values, which is not possible. Let's try another way. Let the numbers be and be such that A, B equals 5, 6 right pointing arrow equals 5x, B equals 6x, 5x plus 4, 6x plus 4 equals 3 quarters right pointing arrow cross multiply. 4 5x plus 4 equals 3, 6x plus 4 right pointing arrow 20x plus 16 equals 18x plus 12 right pointing arrow 2x equals minus 4 right pointing arrow x equals 2. Still negative. This implies there's some error. Recheck the options in exam or revise the question if needed. Let's pick a new question. Question 3. A and B divide 600 rupees in the ratio 2, 3. How much money does B get? Solution. Total parts equals 2 plus 3 equals 5. B share equals 3/5 times 600 equals 360 rupees. Answer. 360 rupees. Let me know the next topic you'd like. I'll continue with the same high quality, no table, full paragraph explanation style. You said. Continued proportions increase, decrease in ratios applications in real life problems. ChatGPT said. Here's the continued, full-length SSC level theory lecture in pure paragraph format covering continued proportions with deeper explanation. Increase, decrease in ratios with concept building and examples. Applications in real life problems, practical and exam focused. Continued proportions, full theory. Continued proportion is a specific form of proportion where three quantities are in proportion in such a way that the first is to the second and the second is to the third. That is, if A, B equals B, C, then the numbers A, B, and C are said to be in continued proportion. The middle term, B, is called the mean proportional, and the third term, C, is the third proportional to A and B. This concept is mostly seen in questions related to numbers, geometry, and progression-based reasoning in SSC exams. The key identity used in continued proportion is that the square of the mean proportional equals the product of the extremes. In mathematical terms, B squared equals a times circa. If two numbers are given, say and B, then the third proportional C can be found using the formula C equals B squared A. Similarly, if A and C are known and you're asked to find the mean proportional B, then you can use B equals square root a times C. Let's take an example. Suppose 2, 4, and x are in continued proportion. Then 2, 4 equals 4, x right pointing arrow 4 squared equals 2 times x right pointing arrow 16 equals 2 x right pointing arrow x equals 8. So, the third number is 8. Similarly, if you are told that a number lies between 3 and 27 in continued proportion, it means 3, x equals x, 27. Then, x squared equals 3 times 27 equals 81 right pointing arrow x equals 9. So, 3, 9, 27 are in continued proportion. This concept is useful not only in number problems but also in geometry, particularly when dealing with similar triangles where the sides are in continued proportion. It is also seen in mensuration-based problems involving scale models or patterns. Increase and decrease in ratios, full concept. When the value of one or both terms of a ratio changes due to increase or decrease, the resulting ratio also changes. Understanding the relationship between original and modified values is essential to solve problems involving population growth, price hike, income expenditure balance, profit loss comparison, and so on. Suppose the original ratio is A, B. If A increases by x%, the new value of A becomes A plus A times x 100. Similarly, if B decreases by y%, then the new value of B becomes B times y 100. These new values form the new ratio, which can be simplified to its lowest terms for the final answer. For instance, suppose the original ratio of salaries of two employees A and B is 3, 4. If it gets a 50% hike and B's salary is reduced by 25%, then A's new salary is 3 plus 50% of 3 equals 3 plus 1.5 equals 4.5, and B's new salary is 4 25% of 4 equals 4 to 1 equals 3. So, the new ratio becomes 4.5, 3 equals 3, 2. Sometimes, you're asked by how much a ratio changes when only one term is increased or decreased. In such cases, always update the change value first and then simplify the resulting pair. You might also be asked the percentage change in the ratio itself, which can be found by comparing the difference between the new and old ratio values, especially if the ratios are in the form of fractions. This concept also applies to comparing two scenarios, such as, if the price of petrol increases by 25%, what is the percentage decrease in consumption required to maintain the same expenditure? This type of question is based on inverse variation, where the product of price and consumption remains constant. If price increases by 25%, new price is 1.25 times the original, so consumption must become 1 over 1.25 equals 0.8, which means a 20% decrease in consumption. Applications in real life problems, practical and exam oriented. Ratio and proportion are not just theoretical topics, they are tools we use in real life constantly. In SSC exams, this real life utility is transformed into practical, word-based problems that test your logic, clarity of concept, and calculation skills. One major application is in division of amounts. Suppose a total sum of money is to be divided among people in a given ratio. For example, 1,200 rupees is to be divided among A, B, and C in the ratio 2, 3, 5. First, add the parts. 2 plus 3 plus 5 equals 10. Then divide the total amount in these parts. A gets 2 tenths of 1,200 rupees equals 240 rupees. B gets 3 tenths of 1,200 rupees equals 360 rupees, and C gets 5 tenths equals 600 rupees. Another classic SSC application is in mixture problems, such as milk and water being mixed in certain ratios. For example, a container has a mixture of milk and water in the ratio 3, 2. If 20 liters of the mixture is taken out, how much milk and how much water was removed? Here, use the same ratio for division. 3/5 of 20 equals 12 liters of milk and 8 liters of water. Work and wages problems also use ratio. If two workers and B are paid wages in the ratio of their efficiency, and it completes work in 10 days and B in 20 days, then A's efficiency is 1/10 and B's is 1/20. Their efficiency ratio is 2, 1, so if total wages are 900 rupees, A gets 600 rupees and B gets 300 rupees. In speed and time problems, ratio is used in both direct and inverse forms. If distance is constant, speed and time are inversely proportional. For example, if one car travels at 60 km/h and another at 90 km/h, the time taken is in the ratio 3, 2. This principle helps solve many real-life situations involving travel time, fuel cost, and transportation planning. In cooking or scaling recipes, ratio is used to maintain consistency. If a recipe uses ingredients in the ratio 1, 2, 3 and you want to prepare triple the quantity, you multiply each ingredient by 3, maintaining the ratio throughout. Similarly, architects use scale ratios when drawing floor plans. For example, a 100 scale means 1 centimeter on the drawing represents 100 centimeters in real life. Profit sharing problems also rely heavily on ratio. For example, if two partners invest 4,000 rupees and 6,000 rupees in a business and the profit is 2,000 rupees, the profit is shared in the ratio 4, 6 equals 2, 3. So the first partner gets 800 rupees and the second gets 1,200 rupees. In currency exchange, unitary method often works with ratios. For instance, if 80 rupees equals $1.60, then we use ratios to find how many rupees equal $5 or how many dollars we get for 400 rupees. All these applications show how deeply embedded the concept of ratio and proportion is in everyday decisions, from business to household management, and how essential it is for excelling in SSC exams. Practice questions SSC level. Question 1. Find the mean proportional between 16 and 100. Solution. Mean proportional equals square root 16 times 100 equals square root 1600 equals 40. Question 2. A's salary is to B's salary is 3, 5. If it gets a 40% hike and B gets a 20% hike, what will be the new ratio? Solution. A's new salary equals 3 plus 40% of 3 equals 3 plus 1.2 equals 4.2. B's new salary equals 5 plus 20% of 5 equals 5 plus 1 equals 6. New ratio equals 4.2. 6 equals 710. Answer. 710. Question 3. 360 rupees is to be divided among A, B, and C in the ratio 5, 4, 1. How much does it receive? Solution. Total parts equals 5 plus 4 plus 1 equals 10. A's share equals 5 tenths times 360 equals 180 rupees. Let me know the next topic and I'll continue with this same in-depth, paragraph-based, no table explanation style. You said, percentage. Conversion of fractions to percentage and vice versa, percentage increase and decrease. ChatGPT said. Here is your complete SSC level theory lecture on percentage, covering basic concept of percentage. Conversion of fractions to percentage and vice versa. Percentage increase and decrease. As requested, the explanation is given in pure paragraph format, with maximum detail and no use of tables or codes. Percentage, concept and explanation. The word percentage means per hundred and is denoted by the symbol percent. It is a way of expressing a number as a fraction of 100. So, 25% simply means 25 out of 100, or 25 100ths in fractional form. In practical terms, percentage is used to compare quantities, express changes, or indicate ratios in a standard format that is easy to interpret and compare. Percentages are used widely in everyday life, in discounts, profit and loss, exams, elections, growth rates, and much more. To understand how percentages work, suppose you scored 60 marks out of 100 in a test. This means your score is 60%, since 60 out of 100 is 60%. But if the total marks were 200, and you scored 60, then your percentage would be 62 hundredths times 100 equals 30%. Therefore, percentage equals obtained value total value times 100. Percentages can also be greater than 100, especially when something increases beyond its original value. For example, if your income was 10,000 rupees and now it is 12,500 rupees, then your new income is 125% of your old income, which means a 25% increase. Conversion of fractions to percentage and vice versa. Converting fractions to percentages is an essential skill. To convert any fraction into a percentage, multiply the fraction by 100 and add the percent sign. For example, to convert 3 quarters into a percentage, do 3 quarters times 100 equals